Hello everybody, myself Jyoti and this is fourth lecture on nuclear energy, and today we are going to talk about how much energy is released in a nuclear fission reaction. Nuclear reaction basically it is nuclear fission reaction. It is basically a very highly exothermic reaction. Exothermic reaction in a sense, whenever nuclear fission reaction takes place, large amount of energy is evolved during the reaction. So experiments have established that the total kinetic energy of the two fission fragments, it is of the order of 167 MeV, which is very high compared to the energy released in ordinary nuclear reactors. But when we calculate the total energy released in a fission reaction, then it is higher than the experimentally established value of 167 MeV. Why it is so? Because when we have calculated the value 167 MeV, it consists of energy only of the fission fragments. That is, suppose we take the example of barium and krypton. Apart from the energy which is released because of the fission fragments, there are other sources of energies as well. Now, besides the fission fragments, some energy is also carried by the gamma rays, which are uh, emitted during the fission reaction, and a few prompt neutrons emitted along with the fragments during fission reaction. They also contribute some energy. To these are added the energies of the beta particles also, because we know that the fission fragments which are emitted, they are neutron rich, so they undergo beta activity, and beta particles are emitted anti-neutron, and we know that whenever beta particle is emitted, it is always associated with anti-neutrino. So beta particle and anti-neutrinos are emitted, and they also, so we haven't taken into consideration the energy of beta particle and antineutrino in 167 MeV. So total energy evolved during nuclear fission is higher than the value given above. So let us look at the values. So kinetic energy of the fission fragments, it is 167 MeV. Then we know that in a fission reaction, prompt neutrons are also emitted. Prompt neutrons are the neutrons which are emitted within 10 raised to minus 15 seconds during a nuclear fission reaction. So generally 2.5, 2 to 3 neutrons are emitted in a fission reaction, and average is taken as a 2.5. So the energy carried by these prompt neutrons, it is also of the order of 5 MeV. Then prompt gamma rays are also emitted, which carry energy around 6 MeV. Beta particles, fission fragments, they are neutron rich, so they emit beta particles, and energy of the beta particles emitted by fission fragments, that is around 8 MeV. We know that whenever a beta particle is emitted, along with it antineutrino is always emitted. So energy of the antineutrino emitted by the fission fragment, it is of the order of 12 MeV, and energy of the gamma rays emitted by the fission fragments, gamma rays are emitted by the fission fragments as well, so that contributes around 6 MeV. So total energy released in fission, it is of the order of 204. Now you can calculate this value 204 mathematically also. So the energy released in fission can be determined quantitatively from the known atomic masses of the nuclei involved, because we know that Q, the amount of energy evolved in nuclear reaction, it is given by the formula sum of masses of the reactants minus sum of masses of the products, and if you multiply the difference in mass with by 931.5, you will get the energy which is evolved. So we know the nuclear fission reaction is like this: uranium 92-235, it captures one neutron, it forms a compound nucleus uranium 92-236, and this uranium 236, it undergoes nuclear fission reaction. It forms two fission fragments, barium and krypton, and along with it approximately 3 neutrons are emitted. So I can write the formula for Q as mass of reactants. Reactants are uranium 235 and neutron, minus mass of the products. Products are barium, krypton, and 3 neutrons, 3 times mass of neutrons. If I substitute the value of uranium 235 atomic mass of uranium 235, it is this value. Then mass of neutron, we know that it is 1.00866 AMU. Mass of krypton, it is 140.9129 AMU. Mass of barium, it is 91.89719. Sorry, mass of barium, it is 140.9129, and mass of krypton, it is minus 91.89719, and 3 times mass of neutron, that is 1.00866. If I calculate this difference in mass between reactants and products and multiply that with 931.5, because difference in mass, it is in AMU, and if I multiply AMU by 931.5 MeV, I'm going to get value in MeV. So Q value which I get here, it is around 200.6 MeV, which matches with the what we have calculated over here. Here the value was 204. So it is almost matching. So this is how you can calculate the value of energy released in a nuclear fission reaction. Thank you. Thank you so much.